So this is a video supplementary lesson to supplement lesson 62 in your textbook, Complex Roots of Quadratic Equations. You'll notice I entitled it Complex Solutions of Quadratic Equations. When they say the roots of an equation, that's just another way of saying that's a possible solution. Okay, I use the term solution here in my title. It's the same thing. So it's going to apply to a quadratic equation. Okay, what is a quadratic equation? The variable, the unknown variable, is the highest power of 2. Okay, so the same procedure we're going to use for completing the square to solve this applies to this as well. We're going to rearrange the equation in proper form in descending order of power with the x squared first, followed by the x term, followed by the number, equating it to 0. Now we know our lead term is 5. It needs to be 1 to apply the completing the square method. So we're going to divide by 5 each term. We are not changing the equality. We're just changing the expression. Since we're dividing everything by 5, it's not changing the equality. But we do get fractions now for the second and third term. As you see, we get a minus 2/5 and a 3/5, okay? But now it's in the proper form for completing the square, okay? And what we're gonna go ahead with our method. We're gonna set up a brackets. We're gonna take that number, the third term, over to the other side. It becomes minus 3/5. We're gonna drop in those first two terms, okay? We're gonna force in a third term, which is going to be 1/2 of the middle term. So we would take that middle term and we would normally divide it by 1/2, but since we already have a fraction, we're gonna instead multiply by 1/2. We would normally divide the number by 2. Instead, we're gonna multiply by the reciprocal, which is doing the same thing, okay? And then after we take half of that value, we square it, okay? That gives us a minus 2/10 squared, or a minus 1/5 squared when we reduce it. And then if we multiply it out, it results in 1/25 positive. So that is the number we go ahead and plop in as our third term in our new trinomial there. Okay, then we can go ahead and factor that trinomial. It factors into a binomial. We take the square root of the first term, the square root of the second term. What was that root that we used to derive that number? It was minus 1/5. Minus 1/5. Okay, and that's going to be squared. Okay, excuse my penmanship here. Okay, and that's going to equal that number over here, minus 3/5. But we added a 1/25 to that side. We must add a 1/25 to the other side to maintain the equality, okay? Let's go ahead and combine those fractions. In this step, we get 15 minus 15 25ths plus 1/25. That combines into a minus 14 25ths. We're going to use that instead of the expression, okay? We're going to take the square root of both sides. That will leave us an x minus 1/5 on this side. That will leave us a square root of minus 14 25ths on the other side. Now, why is this lesson called complex solutions or complex roots? We notice our solution here now, when we express our solution, x equals, that's going to be our solution. It's going to be 1/5. We take the 1/5 over to the other side, plus or minus, and I forgot to say this is the step where we put that plus or minus sign in front of the radical after we square root both sides. It's going to be plus or minus the square root of 14 over 25, but I'm not going to leave the negative underneath the radical symbol. I'm going to express it with I outside here. That's where that complex comes from. Remember, those are complex numbers. okay? An imaginary number. A complex number is a number, an expression that contains real numbers, in this case a real fraction, and an imaginary number. So we have a real fraction, we have a real expression of a radical, we have an imaginary number, we have a combination of real and imaginary numbers. It's a complex number, okay? And we can simplify this solution further by saying that's 1/5 plus or minus the square root of 14 over 5, because we can take the square root of 25. I apologize for this glare here in the window, from the window in the back, but that is our solution, okay? So it's the same procedure, completing the square. It's a little more complicated because we get these fractions involved. It's a little more so complicated because we have a negative under the square root symbol that gives us an imaginary number I on the outside. But other than that, it's the same procedure. Now, in going forward, if you have questions on the homework sets, please text me. That would be the preferred method instead of emailing me. Texting, I can reply to you immediately. I can do it as it comes up. I don't always have my email up and running, and of course with the internet speeds a little bit slower, the emails aren't always working the greatest. I might not get an email till 20 or 30 minutes after it was sent. So shoot a message by text message using my phone number at the bottom of the syllabus, and then I can make more videos with problems like this if you have questions on them. So hope this helps. Again, shoot an email or text message with any questions. See ya.